or teams could be different. And we can have like decentralized team, which is like embedded data team members across different teams within the organization. For example, marketing team can have their own data folks, sales can have their own data folks, as operations, and so on. So in general, we can have a centralized or as well as distributed team with sort of similar skill sets. Given that in mind, I did mention about different roles available in the industry today. Machine learning engineers won't work well if we don't have data. So in general, I have also like been there, done that, meaning during my master's coursework where the business problem would be provided. For example, I still remember working on a problem set of fraud detection, where it's about identifying what are the different fraudulent transactions. So fraud detection is the business topic. The data set is super clean. It's given to me in an Excel file. So I don't have to do anything with it. I directly can jump on my laptop, do some crunching, either in R, Python, any favorite language, and then try and come up with solutions to say, okay, this model is doing good, this model is doing bad. But to take a step back, but we need the data to be in order for us to work effectively. For that, understanding the team is very important. And in Airwallex, we have a combo, or we call it a squad, where we have a data engineer and data scientist assigned together to solve for a particular domain. So we all report to the central data team, but we have dedicated POCs from the respective domains whom we work with. So in general, I have a manager from the technical team. I also have a counterpart in the business team who I work with, and we have a sync weekly or bi-weekly to understand the progress made across the. So in Airwallex particularly, I've included a few domains. For example, issuing is like cards issuance to the customers. We have risk and onboarding, as the name suggests, like onboarding customers and evaluating risk and how might we maintain the platform like without frauds, maintenance. We have growth, which is just saying, okay, we have onboarded customers, how do we grow them? So this is across industry, not just fintech, everywhere. We do have growth related teams which are more towards the product side, I would say. And we have payments, because it's a fintech space, we definitely need payments across different currencies. We have FX, rates are ever changing. How might we provide a better FX rates compared to other competitors? And understanding business accounts and platform. For example, a single user could be a merchant, a sole proprietor, or a platform, which is a combination of different entities working together. So these are the different domain areas where data teams are distributed. And you can imagine this squad will be working in sync with the product owners of these respective teams in order to come up with ML solutions. Applications of ML. I'll take a pause here to sort of give some overview of applications of ML in the industry in general. Then we'll see specific examples of applying ML in our box. So I've worked with Zarura, Uber, like multiple different teams and companies. So in general, applying ML is very close to understanding the users or the business first. And then do we even have the right data? Like not always we need ML. For example, if a marketing person comes to me and understands how might we improve the effectiveness of the campaign. If the campaign is driving, let's say, hundreds of customers, but with the overall value of just $10 or $15, it doesn't make sense to have a ML solution. We just need to make sure that the traffic routing or the lead generation process is effective before we jump into the ML solution. Identify, let's say, what will be the future revenue or how might we forecast this better. So overall, the key deliverable here is understand the business better and then translate that to a data objective. And this data objective will have a lot of different forms, but we need a clear-cut definition of what we are going at, and then trying to come up with a definition. This, in general, is a framework that has worked for me, as well as considered as sort of a thumb rule of best practice across the industry. And let's see how we have structured Airwallex. In general, any problem area in Airwallex, as I mentioned through my previous example, is split into three. We have explore, we have move the metric and recommendations. Explore is like business, closer to the business level. One example could be how might we detect fraud? What is a fraud transaction? And then how might we segment users? How might we understand what the users does on the platform? All these are like very, very vague business questions. So we need a lot of data exploration first to come up with the right metric. For example, if I were to improve the on-site behavior, then I need to understand how many users come in and how many users actually interact with the platform. Then my question or the metric definition of metric would be the number of users and the average time they spend on the platform. If the average time spent is less than 15 seconds, I know for a fact that the users who are coming in are of very, very bad quality, or we deliver content that are not valuable for them. Let's say they click on an ad and added an ad voice by mistake, so they obviously will drop. So we can have main metric that we measure, which is the goal metric, and we might have different guardrail metrics that we measure to ensure that we are moving in the right direction. So those are the move the metric parts, which goes hand in hand with the explore phase. And finally, we have recommendations. So I did include a few other things, like let's say if you have a recommender system, so you might be aware of the different precision recall metrics that we use. You might have studied. One of the key things is average precision at K. MAP is just mean average precision at K. Let's say if I'm showing 3 items, how relevant are these items to the customer? So these metrics come very handy when we are trying to evaluate the ML algorithms or the approach that we use. And finally, the recommendations. Let's say if there is no ML at all. If an operations team is identifying fraud just by looking at the number of transactions and let's say the value it generates, suddenly this average value of a customer is just $100, and out of nowhere they are making a 100K transaction, then it's suspicious fraudulent activity. So this could be an easy business rule. But what if the company really got funding and they are trying to expand? So these may be a lot of false positives. So ML is sort of a support function, and we try and identify like smarter thresholds. Those are some like very basic applications for companies that are starting new, and for like well-established companies, there will be dedicated engineering teams or dedicated teams that work mainly on improving the performance of these companies. Yeah, that's mainly about the segmentation on explore, like move the metric, like identifying the metric and move it in a positive direction, and finally coming up. Moving on. So now coming back to analytics, I wanted to give 3 specific examples. So one of the domain area is risk and onboarding. They're segmented into 3. Here, the domain area, and we have the problem at hand, and what are the techniques that is used. So in a way that it is easy for you to digest. So some fintechs on risk and onboarding. As I mentioned earlier, like customers onboard to the platform, they'll have to submit their KYC documents, which is like know your customer, like who the customers are. Let's say they submit a passport or a driving license or any verification document. It has to be first validated. So which means we need some form of image classification to sort of extract a text from the image, which is image to text. So there are multiple techniques we could use, but overall document scanning is the business objective or the question that we want to solve for. How might we retrieve content from the image onto the systems? And how might we check the validity? That's a different question altogether, where we can check in with other references. But overall, the problem area could be document scanning, for which we use image processing or image to text. And we can have real-time transaction monitoring. As I mentioned earlier, an example of 100K, suddenly it comes up, we hold for a while and understand if this is really causing the reason. Things like banks, they do predominantly these sort of like real-time traffic monitoring. That's very important. And fraud detection and prevention. So if we talk about fintech industry in general, the first thing people can imagine of applications of fintech is actually fraud detection. So because we are bread and butter is we are moving money here and there. So we need to make sure that the platform is safe. So at Wallex, it's no different. So we do have risk models in place, which sort of gives scores for each transactions and also at an actor level. What is an actor? Is basically a customer who does the transaction. If there is a transfer of money between party A and party B, or what is the risk score for each of these? Is that a new party that is being added recently? And what are the things that we can learn from these transactions and improve these models over time? So in a way, we can imagine that DS works very closely with the data engineers to sort of solve this problem. It could be that we use the existing features that we know about the system, but in general, let's say what if it's a new customer altogether? So it's a classic example of cold start problem where we don't know any data about the person who initiates the transaction. Then we look at patterns that are similar in nature, for example, region split. what is the average transaction for that region. So we take that as a reference point and understand or pass through this transaction to say that's legit transactions. So there are multiple business rules which could be over time be refined using ML techniques, and this is why we need to partner with the data engineers as well as the business stakeholder very closely. I did mention XG boost and time series method. This is majority worked in sync for the real-time transactions, or let's say what is the volume that we can expect in, let's say there is 12, 12 or 11. Usually during the holiday season, we have a spike in transactions. So we need to ensure that the thresholds are relaxed in that way. So that's one of the other applications of ML in the risk and onboarding. Yeah. Moving on, growth. This is one of my interesting topics because I've worked in growth predominantly like for the past 6, 7 years across the different industries. So growth in general talks about, let's say we have onboarded a customer. How might we make them come back again and make the repetitive order? So this is like, in general, companies are evaluated based on engagement metrics. As you might have seen in the news, like we have weekly active users, monthly active users. Due to COVID, there are social media platforms where we have surge in the number of these metrics, and so they started hiring a lot more. And now back to reality, the number of these metrics are sort of indicators of how the world is moving and the world is using these products. So growth as a whole, the domain takes care of these sort of entities that is both backward looking as well as forward looking in nature to sort of give some directions about the product team on where we should be working. So one such is on-site behavior and recommender system for product upsells. On-site behavior, I can tell you one example that's sort of fresh or recent that I can think of. Let's say, how might we define if the particular transaction is fraudulent? I talked about, let's say, dollar value. I talked about recency of the transaction. I talked about cold start problem. Let's say if we have nothing of that at all, what else can we think without the transaction history just by looking at the user activity on the website? An easier one could be, initially they start and log in, so that every customer, we know who the person is. So one of the activity is reset password. So reset password is a feature. Usually it's not done so frequently by users who already know their password. But if a user constantly changes the password, then there is like risk that it's being used by multiple people, and it's also being reset multiple times. So which is also the reason why e-commerce companies push for two-factor authentication to make sure that the password sharing is not there and that we have the legit user log and users log. So we can feature in reset password as a, for example, leading indicator for identifying fraudulent actions in the company, and then we can have the data engineers work on features to ingest into the platform, which can be used by other folks, like other domain, like risk and onboarding can easily use this feature defined by the group team. So in a way, it's cross-sharing of signals across different product groups. So that is one of the key areas to focus on, and the growth team or any other team of that matter is assessed by how well we share features with others. So in a way, there is a lot of cross-sharing that's happening, and each week or each month, we have a look back on the projects that we sort of deliver. It could be either like exploratory projects, or it could be like volumetric projects. So when we look back, we sort of try and understand how things go and how might we have better sharing experiences in future. I did include recommender systems here. Unsure like about the familiarity, but in general, recommender systems can range from very simple, let's say product upsells, we can have collaborative filtering or user-based filtering, but all the way to like complex use of recommender techniques. But in general, recommenders, we need proper metrics to evaluate. So these metrics will keep changing over time, and we'll have to look at the prevalence or understand the metrics changes by different region. Each region can have their own thresholds, which needs to be identified. So we cannot have a one size fits all. So that is something to keep in consideration when we are developing the recommender system. Moving on, that would be the final piece that I have for today, which is audience segmentation. As you can imagine, audience segmentation is not just a fintech product. It's across everywhere. Like we can have segmentation for sales, we can have segmentation for marketing. So applying segmentation, what could be one example of a segmentation which you might have applied? Could be k-means, or it could be like any form of clustering techniques. This application could be not just fintech, as I mentioned earlier. It can be customer segmentation overall. We can have T-sneak plots, but the problem with the clustering or segmentation techniques is that one, you need to understand how many clusters can be there. Second is model explainability. So those are the key callouts when we talk about clustering techniques, and how might we better explain this to a C-level audience. So that's also the reason why we constantly change the thresholds and understand, run through the clusters and identify if there are similarities or differences between these. For example, the high value accounts. So understanding the engagement with the platform, high value could be just dollar value, or it could be engagement. So, and then if you run through the clusters today and compare it with 2 months ago, where were these customers? So in general, during my coursework, for example, at NUS, so it was like sort of scratch the surface. Like we run through clustering techniques, do the street plot and understand where exactly is the bend. We just pick that number and see, okay, these are the different techniques, different clusters. And I go ahead and sort of understand how these clusters differ by these groups and come up with summary statistics and say, okay, this cluster, the average value is this, which is why the group of users or any data point or placed in certain order. But in real world, it doesn't stop there, because customers evolve, meaning the usage in the platform evolves over time. So there will be movement across the board. So we'll also have to understand how these customers have evolved over time and what is the cluster movements. So that is something, it's more exploratory in nature, but it sort of tells us overall how these customers behave and what might we learn from these best customers, which we can sort of include for others in future. For example, if I know that the best customers transact, let's say, twice a month, and then they log in 5 or 6 times to view certain product pages, and then they come back. So these are like recommendations that I can directly go to my product team and inform that this is what we should be coding, and this is how we should sort of push the new customers towards becoming high value customers, sort of replicating the user behavior that we learn from the best customers. And I've also included value added services here, which is like a recommender system based on what the customer does. For example, what if scenarios? What if a customer adds to the cart? What if they already purchased it? Are they even interested in the same product criteria? Are they even browsing these category anymore? So these are like features that we can constantly include along the way, and then make sure that the recommenders, even though it's a very best product, but if they already bought a similar product of the same category, there is no point recommending. So in a way, we know that we are informing the recommender system along the way and changing the features dynamically to improve these techniques, as I mentioned earlier, was segmentation, clustering, and basically recommender system. So yeah, I know I've talked a lot. I definitely like include a time separately for like detailed questions. Moving on, please. Yeah, here takeaways and recommendations. I know I've talked for some 20 minutes. A lot of theory, a lot of like examples along the way. But if you have slept, that's totally fine. The one thing that I wanted you all to take away is transfer learning. I'm not talking about the technique of transfer learning. I'm just talking about the technique of how might you apply what you have learned or learning in your coursework and apply it for the industry that you're going to. It could be anywhere. If it's fintech, then well and good. We are all in this fintech workshop. How might you apply this particular technique that you have learned in college, and how might you apply it for fintech? So this is a question that you can ask yourself, and then have this in your profile when you're applying. For example, how might you have it? Then you can definitely go to a lot of sites like Kaggle, where you can practice with the data sets that is available, like be a part of a community. So basically, try and apply what you have learned in the industry that you want to go. Yeah, moving on. I've included a bunch of recommendations here. This is from my own personal experience. Get the foundations right, which is like nobody's going to give us a SQL or a CSV dump for us to work. So this is the first reality. So you will have to get the data yourself, which means you need to know SQL. If you don't know, just go ahead and learn from the internet. SQL is like bread and butter. Everybody should know it, irrespective of the technicalities. Try and get familiarized yourself with data visualization techniques. There are multiple different tools out there like Power BI, Looker. There are multiple different. So make sure you at least have a firm hold on one of these to sort of understand how you can pull the numbers yourself, connect to the DB, get some basic numbers like trend over time. So this will give us some form of head start in exploring the data, and definitely read more of the engineering blogs on the companies that you frequently use day in and day out, and understand how they have metrics and how might you sort of take inspirations from those for the industry that you apply. And of course, build a portfolio. This is definitely must. There are a few things that I've included. Not sure if this is super familiar, but I felt that these are like things that are usually not taught in school. For example, Omdena, it's an AI solution for tackling real world problems. So you can go, it's a community where you can do ML projects which are industry related. You can join them as a senior or junior DS or ML engineer. You will have a category or like a country lead. So solving problems like in Africa, how do you eradicate polio? Like there are multiple different like social related activities or social related problems that you can go in, check, be a part of the community. It's free, join and sort of have this as a pet project going on the site. So in a way, you would have applied ML in real world, as well as explore some ML ops frameworks. So the data science, machine learning, this field is ever evolving. So ML ops is, who have heard about ML ops here? It's totally fine. And then definitely have ingested something new in your heads today. So it's a good takeaway for me. ML ops is like, there are multiple different frameworks for you to apply. For example, ML techniques. One example is, we all know, let's say if we run regression techniques, or if we are running a decision tree to solve for a classifier, right? How does the threshold change over time? Which parameter gives me the best value? So in general, all these we would have done it like manually, taken a note of the different, let's say, metrics over time, and we pick the best metric, right? That is how we usually do. But these MLOps techniques just go one level beyond, which is like a GitHub for experiments that you run. So try it out, have some fun exploring the data, not just exploration, but also exploring how you do along the way. For example, which experiments are won, meaning the metric, and which experiments are something that you can learn or like give recommendations to. And 1DB, it's called Weights and Biases. So it's another MLOps platform which you can use, or DAX Hub. These are all like open source. DAX Hub is definitely something I would recommend too. Analytics engineering is another interesting topic. DBT is the tool that is used for sort of transforming the data along the way for you to work on these projects. So there are multiple avenues for you to become an ML engineer. So pick the ones that's exciting for you and ensure you definitely enjoy the job. Yeah, I think that's all I have. Do check out the open roles with AdWorks, and if you're find something interesting, you can also reach out to me. Yeah, that's all I have for today, and happy to have any questions.
Yeah. So thank you, Krishna, for the talk. So we're now opening the floor for any questions that you guys would like to ask Krishna himself.
Any questions from Zoom? Happy to have them. Yes.
Yeah, you mentioned your recommendations systems for customer segmentation.
Right.
Is it applicable only to e-commerce or
Sure. Yeah. Thanks for the question. Customer segmentation is not specific to e-commerce. For example, I started in the e-commerce field. I have worked in like product. I've worked in operations side. Customer segmentation as a technique can be applied across the. The thing to be very careful about is, as I mentioned earlier, how might we replicate the same results at a later stage? So, which means you will need to understand what are the different, let's say you analyze the data and you come up with 3 clusters. and why have you come up with 3 clusters, and to understand more about these clusters is something you have to do. Whenever you talk about customer segmentation, it's synonymous to documentation for it. Because at this stage, at this data set, you are looking at this time frame, this is the time. And let's say if I refresh the same, it would be good. So documenting which customers went on to which bucket is even more relevant to understand or apply across different industries in Singapore. For example, we could apply the same technique in transaction custody, like transactions and trying to segment the users based on transactions. You can segment the users based on their behavior, and segment the users based on their property. For example, which industry they are. So there are multiple ways to segment.
So for the techniques that are currently being used for data scientists in the Web3 space, is it similar to the Web3 space whereby you can pull data from the document explorers to analyze as well? Or is there additional programming language or knowledge that you need to know to be able to pull those data?
Understood. Yeah, that's a very good question. How might we integrate from Web2 to Web3? Right now, majority of the techniques that are in Web2, and let's say we are talking about Web3. So data pool, the techniques that we use might be different, but applications would be similar to Web2 space. For example, if we are talking about graph PV, how might we have that relationship and transform that into, let's say, in a tabular form, where we can use the tried and tested techniques, and how might we apply the same sort of metrics over time for improvement. So yeah, techniques remain similar. The way we look at the data is what differentiates.
So, thank you.
Any other questions? Hopefully, you are all able to learn a thing or two from this session.
Could you explain a bit on the difference between the responsibilities of machine learning engineer and data science?
Yeah, of course. Maybe I can take a step back really and explain other rules too, so that in a way it's easier for us all to digest the rules available in the market. This is a common question, and it's always confusing to understand why certain rules exist. So your question is on machine learning engineer and data science. I'm going to answer a few more rules so that it's even more clear. Closer to the business is the business analyst, and one level above is the data analyst. Business analyst responsibility is mainly to understand what the business needs are and how might we tackle that problem. And basically, it's a means of, it's like a wrapper around the data team where business analysts communicate frequently with the stakeholders. So that's one. Second, data analyst. Data analyst is just one level above the business analyst. The skill sets is similar, plus data business intelligence tools, usage of BI tools, for example, Power BI, Tableau. So these data analysts are pro in these using these tools. So in a way, it's easier for them to build dashboards or solutions where the C-level people can directly look at. So they work hand in hand with the business analysts in order to get the job done. So we talked about business analysts, data analysts, and let's move one level above, which is data scientists. So they should have the two plus statistic techniques and applying basic sort of exploratory analysis and how might we do certain things. For example, they can do machine learning in a notebook. Are you familiar with the notebook environment? Like to be Python or R. So it's like you do it, you create a proof of concept and you showcase it to the stakeholders through the business analyst or through the data analyst. So in a way that they already needs to know business and data analyst responsibility. On top of it, they should understand the techniques. And one level above, we have the machine learning engineers, where you do everything as well as productionize this machine learning code that you write in notebooks into the real-time environment, which is the productionizable version of machine learning models, where I talked about ML ops, which is like ongoing operationalizing machine learning. So you need to have that skills as well in order to be effective as a machine learning. And there is data engineers who, without them, the entire data team is nothing. So those are the superstars who sort of day in, day out work on cleaning the data, having a baseline for the teams to work on effective data. Garbage in is garbage out. So we need to have a proper pipeline to have the data engineers. So we have data engineers. And in companies or in the US, for example, we also have research engineers who work extensively on problems that doesn't have a clear-cut solution, or basically they are researchers in-house who work on novel models. For example, it could be that, for instance, Uber, for example, might have a research team who sort of detects with the camera open if a driver is sleeping or not. How might we alert them? So these are research problem or open-ended questions. So we have research engineers. Hopefully that answers your question, President. Okay. Very good questions, though. Any others? Yeah.
Great. So, with the framework that you set up, as a business analyst or data analyst, how deep must your technical skill sets be?
Sure. If you ask me, it should be more deep than just learning or knowing to play around with Excel. You should definitely know SQL. If I were to talk more, then SQL, as I mentioned earlier, is just like English, how we communicate. SQL is a language for you to talk and get the data back. So one level below the data engineer, one level above the business analyst would be the data analyst skill set. If I were to rate them in the order of like knowing what tools, what are the responsibilities for it. It's not too shallow, it's not too deep either, because you get graduated, or it's totally depends on interest. For example, if you're visually, if you like the numbers to be sort of presented in a nice manner, and if that is what motivates you, there's no harm in continuing to be a data pro data analyst, who even the data scientists or the ML engineers look up to for any questions related to data. They will be the first person to answer, are subject matter experts. So the levels here are not the order of priority, or not the order of the salary which they receive. The levels here is basically the skill set and the experience that they have on each of these things. So at no point I'm saying that business analyst is definitely less compared to an ML engineer. All these are equal, just the skill sets is different, and the industry experience and the likelihood of they staying on the job will give them more knowledge on day in and day out, so they become subject matter experts.
Let's say for a company that's actually starting up, usually what are the roles that they start hiring first?
Perfect. Thanks for the question. This is something that is constantly evolving over time. For a well-established business, we might have these many roles. Let's say for a very, very new company, what should they have? They basically have one person or two person doing everything, from talking to the business, understanding or getting the data. They act double down as business analyst and the data engineer to get the job done. They create ML models to productionize them. So they also double down as an AS and an ML engineer. So in a way, companies, if you were to ask me, companies should start by hiring a data engineer, because that is the first thing that they should be looking at to get the data foundations right, and get one person, that could be an ML engineer or a DS, depending on their, for example, it also depends on the vision for that particular person. If they want to work on a group, then a startup might not be the best option, because in general, startups are very easy in the sense you have to do everything else. So the data engineer who's solid, and data scientist or ML engineer who can work together. So it's like a squad that we work with everyone. So data engineer to get all the questions with data, and DS who works directly with the product team, and as well as double down on building proof of concepts for future products.
Thank you.
What do you guys do about concept? You guys use
NLP currently is still not used in production, but definitely we have a few people, like interested folks, working on these techniques to understand how might we apply NLP in. For example, there are support tickets that are generated. Let's say users reach out for either through email or through call centers. So we have a log of all these transactions. So we try and group these calls based on topic classification, which can then be used saying, okay, majority of the customer complaints are related to either login issues or something else. So this is a work in progress. Hope I answered the question.
I think we can take one last question. And maybe from class. I'd like to ask, how would a normal technical interview go for data scientists or engineers?
Um, Data scientists and data engineers are two different tracks altogether. Maybe I'll talk about the data scientists next. So in general, you have an intro call with recruiters, and you will have so basically that tests your idea about the role. What is that you learn? What do you expect out of the role? Next, you will have a meeting with the hiring manager to sort of sense check if you are overall a good fit, and then you will go through the loops. The loops will have first technical rounds, which tests your ability to write SQL. It could be a combination of SQL and Python or R. So in general, they'll give you a data frame. For example, can you manipulate these on the fly? Which means a few companies have actually like asked you to share the screen. They allow you to use Google, and now you can use ChatGPT, which is directly with answers. But in general, it's more about understanding, can you solve this versus do you know how to solve this? So that's mainly how the companies are evolving now. After you have cleared the technical skills, you have product sense rounds. If you are applying for a product specific interview, product DS, for example, can you come up with the right metrics that sort of maps to this specific business problem? So these are case-based where there is more open-ended in nature and sort of test your ability to think of, can you apply, or basically common sense versus are you talking about ML techniques right off? So it's about applicability for the business. So those are product sense related questions. And then you might have one or two rounds depending on the company that you apply for. But in general, you have a tech round, you have a product sense round, and then you have a stakeholder round, which is like how will you interact with other stakeholders when you are pushed into certain situations. So there'll be questions around how might you deal with this. So again, there are no right or wrong answers, but these are the levels that you should clear when you are to be a DS. For DE, it's more technical in nature. So test on SQL, test on writing pipelines. It could be open source Apache Airflow or any tool that you know of. But to start as a fresher, you will not be asked in detail. But if you're talking about a 2 or 3 years experience, definitely you need to show some sort of background in writing like the pipelines. Yeah. No questions from the online viewers? No? Cool. Thanks a lot, everyone. Thank you.